So this third lesson concerns timbre, and we can give this a little bit shorter shrift because timbre, the third of these qualities that characterize our hearing, is not very well understood and not very well studied. But I need to define it for you and explain its causes. And let's begin with the definition. So timbre is the quality that distinguishes signals, sound signals, and what we hear when the intensity and the frequency are the same. So obviously if you play a clarinet and a bassoon at the same intensity and with the same notes, the same frequency of vibration, they sound very different. Well, why is that? This difference is what's referred to as the timbre of the subjective experiences that we have when we hear stuff. And the reason is, first of all, the resonance properties of the instrument or the voice, which again we're going to be talking about in a subsequent module as a perfectly good musical instrument in singing. But whether it's the voice or a musical instrument, the resonance properties of the clarinet, the oboe, the guitar, the violin, they all have quite different properties, and at the same intensity and the same frequency, you hear a very different sound. So part of it is the resonance properties of the body that's attached to the instrument. You remember when we tapped the tuning fork and held it to the table, the tuning fork itself was just the vibratory energy of the tines of the fork, but when we held it to the table became the attached body to the tuning fork, and you heard a much louder sound that was affected by the properties, not very musical properties, of the table itself. So the things in addition that affect the timbre of the sounds that you hear are the number of harmonics in the signal. So when we listen to the effects of that diagram that I just showed you before in the last lesson, and you've left out some of the harmonics, and you were missing the fundamental and the low harmonics but have only the higher ones, then the sound is much tinier, and the timbre in that sense is quite different than when you have the low harmonics as well as the higher ones. A third thing that affects the timbre, causes the timbre that we hear and affects what we experience subjectively, is the rate of attack and decay. And by that I mean how fast the signal is rising and decaying. You can have a rapid rate of attack, a slow rate of attack. You can think of this as the envelope that is enclosing the sound signal in time, and it can vary in different ways and at different rates, and that's another cause of timbre. And finally, the amount and quality of the noise that's in the signal affects the timbre as well. So I told you before that you have a range of sound qualities from and physical sound signals ranging from highly repetitive tones to the other extreme, which is white noise, and most sounds, of course, are somewhere in between. And the amount of noise in a signal, and there's always some noise in realistic signals, in music, in the voice, in natural sounds that we're exposed to every day, the amount of that noise and the quality of that noise affects timbre as well. This is another good point to bring in a demonstration of how different timbres are in the context of music. And what Ruby's going to demonstrate now is an ascending scale played on the mbira compared to playing the same scale on a piano. The mbira, I doubt that many of you have heard of that, but that's a Zimbabwean instrument that is very popular in Zimbabwean music. And the timbre, even though these two scales are played with the same intensity and the same frequencies, the same notes, this is just an example showing you how different the quality of the sound can be based on these timbral differences and the causes of the timbral differences that I'm referring to here, or that I've explained to you here.